So today let's talk about distributed system lecture 11. So what is distributed system? Distributed system is a collection of independent computers that appear to its user as a single coherent system. And the goal of distributed system is to easily connect user and resources to achieve transparency, openness, and availability, performance, and scalability. So the connecting users and resources we have. So what are the resources? The resources are the computers, the computing power, the data, the printer, the sensors, and mobile devices. And the reason why we are sharing is that the communications, the economics and business, the collaboration and information exchange, there are some problems as well. For example, the security, the coordination required, and the fairness. The transparency in the distributed system appears to its user as there is only one single coherent system, which means that the system appears to its user as only a single computer. Yeah, so we hide the system. Maybe the high system from the fact that they have delays, they have multiple servers, and so forth. There are many aspects of the transparency. For example, the access transparency, the location transparency, the migration transparency, the relocation transparency, the replication transparency, the concurrency transparency, the failure transparency, and the persistence transparency. The access transparency hides the difference in a data representation and how a resource is assessed. Just like just to tell you that how you have, maybe you go to that folder, and that folder to get this information. However, in terms of the location, it's just like where the resources is stored. Maybe it's stored in this database or that database. The migration is that has the information from moving from one place to another. Just like if you move this information from here to here, from here to its user, that there is no difference because we do not know that. The relocation transparency indicates that the resources may be moved to another location while in use. Yeah, just like what's the difference between the migration and the relocation while in use? Oh, I see. So migration is something that happened in before, and relocation is something that we are doing now. The replication has the resources is replicated, which indicates that the resources is has the resources is replicated. Yeah. For example, if you have 1,000 data, and you just replicate 1,000 times. If you update one, you are going to update 1,000 times. And the concurrency means that the resources may be shared by other several competitive users. The resources may be shared by several competitive users means, for example, many people can access the same website at the same time. For example, the failure that has the failure and the recovery of the resources has the failure and the recovery. It's just like if it fail, it's one node failures, you can still access it. The persistence is hide whether resources is in memory or on the disk. Hide whether software is in memory or on disk. Just like persistence. I'm not sure what does persistence mean. where the resources in memory or on disk. And then now let's go on to the degree of transparency. The transparency is not always applicable because users may, for example, if you use shadow socks, you must know which server is on which continent. Maybe in China we use Hong Kong servers, and so forth. We must know. Maybe we do not want to use the UK one because the geographical distance is too long. Not always possible. We can sometimes having the failures is not good, and you cannot distinguish how slow a computer from you cannot always distinguish a slow computer from a failing one. Sometimes we need to clearly distinguish the fault. And there's a trade-off between a high degree of transparency and the performance of the system. We need to make a trade-off between them. The reason why is that what if you have a high degree of transparency? Let's say it's replication transparency. You have many data, but you must coordinate. You must coordinate between them. Therefore, if you update one, you're going to pass this update to all your replicates through this network, which costs money. Therefore, it impacts your performance. The open system offers services according to the standard rules that describe the syntax and the semantic of the services. It offers the service according to the standard rules that describes the syntax and the semantics of the services. You can enjoy natural and complete specifications. For example, that the openness just say everything, no matter whether you are Raspberry Pi, whether you are a supercomputer, as long as you follow the service you can join. Reliability means that we are trying to maximize the availability. The performance means that we want to reduce the global delay, the heterogeneity, not always cooperative. The scalability means to scale in size, in geographical. The one important thing is the administrative. That's like if there are many administrative nodes going to be on this network. For example, there's a central service, means there's CPU, only one CPU, and only one computing node centralized data. That is the channels, the information to be shared, and the centralized algorithm is whether you can do some routing based algorithm, and whether you are the god of the algorithm. The scaling technique is asynchronous communication, and which hides the communication latencies and tries to avoid waiting for responses to remote services. Requires as much as possible distribution replication. They are asynchronous communication is illustrated as follows. You can why scaling technique?为什么 scaling ASYN. And the distribution means the asynchronous communication is that we can send the packages using TCP to data packages to there. Distribution means that it's like a DNS namespace. Replication means that we are going to the caching means that we only read data for new pages, and replication ability is going to increase the availability. Balance to the load, reduce the communication latency, cause the consistency problem, because you need to synchronize something. And we cannot assume that the network is reliable, the network is square, the topology does not change, the latency is 0, the boundary is infinity, the transport cost is 0, there is one administrator. And that's all for today.